Hi everyone, this is Mrs. J, and today we're going to be graphing polynomials from factored form. First, please pause the video and give this warm-up a try. Okay, go ahead and check your work here. Remember, the leading coefficient tells us the end behavior on the right. So if the leading coefficient is negative, the right side goes down. If the leading coefficient is positive, the right side goes up. The degree tells us if our end behavior matches. So if your degree is odd, the end behavior is opposite. And if your degree is even, your end behavior matches. And please note that for part B, this was not written in standard form, so it helps to rewrite it before you determine that leading coefficient and the degree. So today we're going to be actually putting together our entire graph. We're going to be graphing polynomials from factored form. So we're still going to start by using our leading coefficient and degree to determine our end behavior. And I do little arrows like you saw in the warm-up. Then we're going to find the zeros, which are the x-intercepts, and we plot them. And then we're going to find the y-intercept by setting x equal to 0, and we plot it. And then we're going to try to connect the pieces. And if we're able to connect the pieces, then it means that all of our characteristics are probably correct. And you will see that today we're doing very rough sketches, so I'm not going to scale the x or y axis at all. I'm simply going to label the intercepts. Okay, let's give this first one a try. So for the leading coefficient, you would just look for the coefficient out front here. If you were to expand out this polynomial, your first term would be 1x cubed. So our leading coefficient is 1, which is positive. So I'm going to draw a little arrow facing up and to the right. Then, for the degree, you have to essentially count, when it's in factored form, you have to count the number of x's you see. So I see 1, 2, 3, so our degree is 3. If we expanded it out, the largest term would have x cubed. So since the degree is odd, I know that the end behavior is opposite. So if this side goes up, this side must go down. Next, I'm going to look for my x-intercepts. So to find x-intercepts, remember we set y equal to 0. So you're essentially replacing this with 0. And it's essentially using zero product property. It's going to be all of the opposites of what you see in your factor. So our x-intercepts are at positive 5, negative 3, and 1. So you can go straight to this step, but this is just how we get it. We set y equal to 0, and we're just using zero product property. But just remember, the x-intercepts are opposite of what you see in the factors. So watch what I'm going to do again. It's a super rough sketch. I'm just going to say, okay, this is negative 3, this is 1, and this is 5. It doesn't need to be scaled at all. And then I need to find my y-intercept. There should only be one. We do this by setting x equal to 0. So we have f of 0 equals 0 minus 5 times 0 plus 3 times 0 minus 1. So negative 5 times positive 3 times negative 1, which is positive 15. So again, super rough, nothing is scaled. I'm just going to say, okay, this is 15. And there you go. Okay, so we know that our graph can only cross the x-axis at these x-intercepts, and we know that our graph can only cross the y-axis at our y-intercept. So now we're trying to connect this arrow on the left to this arrow on the right by only crossing our axes at these points. So let's get started. So here I'm going to cross through here. I'm going to cross over here. I can cross at 1, and I can cross at 5. And there you go. So I do want to point out that this is a super, super, super rough sketch. Okay, for now, we're just focusing on end behavior, finding the zeros and the y-intercepts. What's happening in between, we would actually just need to plug in more values. We could plug in f of negative 2, f of negative 1, f of 2, 3, 6 to get a more accurate graph. So again, what's happening in between, we would need to do more work to make a more accurate graph. This is a super rough sketch, but it gives us a really good idea of what our graph looks like. All right, let's try another one. So here we can see that our leading coefficient, which is right here, is -1. So it's negative, which means the right side of my graph goes down. So I'm going to start by doing a little arrow. For my degree, if you count up the number of x's, 1, 2, 3, 4. The degree is 4, which is even, so my end behavior matches. So the other side must also go down. For my x-intercepts, we can just write those out. We have -7, +5, +2, -3, always opposites. So again, super rough. Here's -7, here's -3, here's 2, and here's 5. So I have 4 x-intercepts. And for my y-intercept, we're going to find f of 0. So -1 times 0 plus 7 times 0 minus 5 times 0 minus 2 times 0 plus 3. So -1 times 7 times -5 times -2 times 3. So f of 0, or our y-intercept, is -210, which is why we're going to be graphing without worrying about the scale. We just need to make sure we label it. So remember, our goal now is to connect this arrow to this arrow. While going through these points, we have to go through these points, but you cannot cross your axes anywhere else. These are the only times you can cross your x or y axes. So if I start going through, let's see, I would have to cross over here, go through here. I'm going to jump over the -3, cross over here, and cross over here, and then I can connect my arrow. Okay, so again, how high does this graph really go here? Well, I don't know, maybe it goes like this. Maybe it goes way up here. The same thing here. We don't really know what's going on in between unless we make a table of values and plug in some additional points, which we could easily do. But for today, again, we're just doing a rough sketch. So I'm looking for the correct end behavior, the correct intercepts, and the correct general shape of our graph. All right, let's try another one together. So here I can see my leading coefficient is 3, which is positive. So I go and I put a little arrow facing up. Now here, when I find my degree, don't forget about that x out front. Even though you're not adding or subtracting anything, it's still a factor. It still has a 0. So I have 1, 2, 3, 4. My degree is 4, which is even. So that tells me that my end behavior should match. Both sides, in this case, will go up. Now when I list my x-intercepts, this x out front is an x-intercept as well. It's just like adding or subtracting 0. If you don't see anything next to x, the x-intercept is 0. So this does tell us an x-intercept. You cannot ignore it. It's an important part, and your graph would be wrong. So we have an x-intercept at the origin. We have an x-intercept at +4, -2, and -6. And if you have an x-intercept at the origin, that is also your y-intercept. You can only have one y-intercept, so if you're already crossing at 0, you can't cross somewhere else. And then other points, we have -6, -2, and then we have 0 and 4. So those are the 4 x-intercepts. So again, I need to connect my arrows by only crossing my x and y axis at those 4 parts. So I can go down, back around, through here, and back through. Again, if we wanted a more accurate graph to see, oh, maybe my graph goes like this, maybe my graph goes like this, we could achieve that by plugging in more values in between. But for today, this is going to be good enough for us. Okay, so go ahead and pause the video and give this one a try on your own. Okay, go ahead and check the different features. The leading coefficient is negative, so the right side goes down. The degree is odd, so the left side should be opposite and should go up. our x-intercepts are positive 3, negative 7, and negative 2. And our y-intercept is 210. So the only way to connect the dots is for your graph to look something like this. So there is one extra thing we need to watch out for when we're graphing from factored form, and that's zeros with a multiplicity greater than 1. So what is a multiplicity? It's essentially, this is a casual way of stating it, but it's the number of times that zero is a solution. Okay, so the number of times the zero is a zero. So if you look at this function, we see, okay, we have an x-intercept at negative 2. Since the factor is just x minus 2, there's no exponent, this x-intercept has a multiplicity of 1. So it's just a normal 0. It's just like the ones we've been working with. But if you notice here, this factor says x minus 3 squared, which is like saying x minus 3 times x minus 3. It's happening twice. So at that 0, at positive 3, this 0 has a multiplicity of 2. So something different is going to happen when you have a multiplicity that's bigger than 1. So we'll talk about that in a second, but this multiplicity would be 2. Then here we have the x-intercept at negative 5. Notice it's x plus 5 cubed, so it's actually like having that factor 3 times. So this 0 has a multiplicity of 3. Okay, so what? So what if it has a multiplicity greater than 1? Well, something happens graphically when you have a higher multiplicity. So if you have a multiplicity of 1, your graph travels straight through it. It's just a normal looking 0. However, if you have any type of even multiplicity, like a multiplicity of 2, 4, 6, so on and so forth, your graph is actually going to touch and turn. It's going to touch and turn at your axis. So it kind of does something like this. Okay, so it's not actually going to cross over the x-axis. It touches the x-axis and it turns. Now, if you have an odd multiplicity, something different is going to happen. It's going to flatten out, but it does continue and it does cross through. It kind of makes this like almost an S shape. It kind of does something like this. It looks like a cubic function. Sometimes it's a little bit hard to graph, so you can kind of over-exaggerate it, but it's not just going straight through. You have to show that it is flattening out, but then it will cross over and continue on. So even multiplicities touch and turn, odd multiplicities flatten and continue. Okay, let's try this example together. So let's start with our leading coefficient, which is negative 2. And again, since it's negative, the right side goes down. Then I'm going to look at the degree of our function. So I'm going to count up the zeros. 1, or the x is 1, and this one I'm going to count twice because this factor is happening twice. So 1, 2, 3. My degree is 3, which is odd, so this side goes up. Now for my x-intercepts, this factor of x does have an x-intercept at 0. Don't forget about that. Now this one has an x-intercept at negative 3, and I'm going to make a little note. It has a multiplicity of 2. So I know something fancy is going to happen there. So here's negative 3, and then here's 0. Then remember, if our x-intercept is at 0, so is our y-intercept, because you can only have one y-intercept. Okay, so let's say you didn't know about multiplicity and you tried to just connect the dots. You would go through the negative 3, go back through the 1, and you wouldn't be able to connect your arrows. So hopefully you see that something is wrong. So remember here, at x equals negative 3, your graph is going to touch and turn. So it won't actually cross over. So I'm going to go up to negative 3, and it's going to touch and turn. So it looks like this, okay? But now, I still need to turn back around and go through my x and y-intercept at the origin, like this, and then I can connect my arrow, so something like this. So remember, when you're doing this, you can't cross at any other place on your x or y axis besides your intercepts. So if your arrows aren't matching up with the intercepts you have, maybe you're missing a multiplicity. So again, if you don't know about this touch and turn, you're not going to be able to connect your arrows successfully. Okay, let's try this one together. Here I can see that my leading coefficient is positive 1, telling me the right side goes up. And my degree, if I count up the number of x's, I count this 3 times. 1, 2, 3, and then 4. So it's even. So my end behavior should match. For my x-intercepts, I have positive 5, but you can see that that has a multiplicity of 3 because it is cubed. And then I also have one at positive 1. That just has a multiplicity of 1, so I don't have to worry about anything fancy graphically. For my y-intercept, I can do f of 0. So 0 minus 5 cubed times 0 minus 1. So I have negative 5 cubed times negative 1. Negative 5 cubed is negative 125 times negative 1 gives us positive 125. So again, I'm going to do a really rough sketch here. Here's 125. Here's positive 5. And here's positive 1. Okay, at positive 5, I know that we need to have a flattening out. It flattens but continues over. And then everything else should just cross normally. So here my arrow's kind of way out of the way. I'm just going to redraw it over here. I'm going to go through my y-intercept. I'm going to cross normal. Here's the part I really need you to over-exaggerate. When you come up to the 5, it needs to flatten and cross. So something like this. Again, we're really over-exaggerating it. So you're kind of showing me that you know what happens when we have that odd multiplicity. It flattens but continues. And again, I just redrew my arrow, so it was easier for me to connect with my y-axis. So you can go ahead and just ignore this arrow on the left. All right, so go ahead and pause the video and give this one a try on your own. All right, go ahead and check your work here. The right side is going down because my leading coefficient is negative. The left side matches because my degree is even. Let me add that in. For my x-intercepts, I have x-intercepts at negative 5, positive 6, and 0. But since the x factor is squared, this 0 has a multiplicity of 2. And I know even multiplicities touch and turn. So as I go to connect, I'm not actually going to cross over at the origin. I need to touch and turn. And if you don't know that, you won't be able to successfully connect your arrow. So it is a very important characteristic of these graphs. Okay, here's one last one for you to try on your own. So again, pause the video and give it a shot. All right, go ahead and check. The leading coefficient is positive, so the right side goes up. The degree is odd, so the left side is opposite and therefore goes down. At the x-intercept of 4, I have a multiplicity of 2. So you'll see that graphically I have that little touch and turn. And then for my x-intercept at negative 6, I have a multiplicity of 3. So you can see that I have that flattened but continuing shape. And then here's my y-intercept at 3,456, which is why we are not drawing these graphs to scale. Okay, that is all for today's video. Thank you so much for watching.